We know NPN, we know PNP.
Yeah.
What shall we do next?
So VB on, how will I give? Means you are changing VB on to VB1, VB2.
That's right.
So how is it actually done?
Okay, so let's see.
Hmm.
Let's do the dumb way of doing it.
Hmm.
And
Give
then
me some idea.
Yes. So suppose I do like this, right? I'll close the loop like this, no? Suppose I do like this, and I will ground it for reference purposes easily. So
this is for NPN.
this is for NPN. Okay. If I do this, no? Well, this is some V in there. Shall we call it V in? So this V in will be applied directly across VBE. And this will cause some current to flow, no? Some IC to flow, and I want exactly 0.7.
Yeah.
And I want to change the IB. Oh, I'll have to change this by from the third decimal place.
Correct.
So that is going to be very hard.
Yeah.
Right. This is going to be too hard because I can't put a voltmeter and check.
Yeah.
Correct?
Yeah.
This is too much. So I don't think we can do this easily.
So what is the way forward?
See, the easiest way, I put a voltage across a resistor and then I get a current. That is my easy way. Right? I need to figure out how to do that. In fact, even with the diode, you have the same problem, no? If you want to turn on the diode, you can't just apply a voltage on the diode to turn it on.
Correct.
It is part of some circuit.
Correct.
And then you apply DC or AC and it turns on or not. We need to do something here. We need to build a circuit around this.
So you want to connect this to some power source?
Some power source, right? And so we also need to make sure that the device is in the forward active region.
Active region.
Active region, right? So if it's active, VCE needs to be higher than VBE on.
Correct.
Right? That also we need to do. Right? So maybe we'll start with that. That is a good idea. So what I will do, shall I connect a battery here? I'll connect it like this to start with.
Okay.
Right? In fact, I can connect a resistor also there. We'll just connect a resistor there. I'll draw it like this. Nothing wrong in connecting a resistor. There.
Okay.
Okay. So maybe I'll call this, it's going on the collector side, I'll call it VCC. Collector side resistance, I'll call it RC. Okay. But this is okay. So now I can make sure this is VCC is very high. So as you can see, VCE, no, when it is very high, it is in the forward active region. So I can choose VCC high enough
that it is in
it's in the active region. But I still have a problem with this, no? Shall we try connecting a resistor?
The other side also?
The other side also. Shall we see what happens? I'll call this RE.
Okay.
Now I can apply a battery at the base. No?
Let's try.
Let's try it out. So I'll call this some VB. If VB is very small, no, less than VB on, then nothing will happen.
Nothing will happen.
Nothing will happen. Now, if it is exactly VB on, so let's say VB is some 0.7, right?
Then it will be in active region.
It will be in active region, and this will be 0.7, no? But then this voltage is 0.
Yeah.
No current will flow. Correct? So this is also not good. I probably need to choose VB greater than 0.7. Right? Then what will happen? This will not be 0. This will be greater than 0.
Okay.
Then some current will flow. Looks like. Okay. So shall we write down the voltages?
Yeah.
So what I will do? So if I choose VB greater than 0.7, then the voltage here, so the emitter voltage is VB minus 0.7. correct?
That's
so that
true.
is the voltage here.
Yeah.
And now the current, which is the emitter current,
IE.
IE, is just the Ohm's law.
Yeah.
Oh, this is nice. I think your idea to modify the circuit by adding a resistor works very well, because I can now choose, no? By choosing RE and VB, I can now choose to create an emitter current in the device.
Okay. Okay.
Okay?
So there will be a corresponding collector current also.
Correct. In fact, it should be the same, no? Or very
Only
close
alpha
to that.
times, yeah.
Only alpha times. So this will be IC, maybe very close to IE. And now we need to find out the collector voltage. So the collector voltage, VC, how do we find that out?
VCC minus
That is true, right? It will be VCC minus
IC
ICRC. Correct, because we can't use the collector emitter voltage.
Yeah.
Because there is a large range of collector emitter voltages
Yeah,
for which
so
the device works.
Correct.
Correct, no? So VCC. Oh, perfect. Nice. So now I can choose VC, I can choose VE, I can choose them to be large enough such that it is well in the forward active region.
Okay.
Nice. Okay.
This VB we have to connect battery only. Is there any way? Any other way?
Correct. That's true. See, we are using two batteries actually.
Correct.
Let's at least try to remove one of them. No?
Yeah.
Remove one of them. Okay. See, what I found is from this curve, VC can be very high.
VC
can be very high. But VB is
small.
0.7. In fact, we have magnified it, no? This, you'll get a whole bunch of
Correct,
curves
correct.
which are very close.
Correct.
0.7, 0.705, things, things like that.
Correct.
So VB is always going to be very close to 0.7. So I think we should try to make VB from VCC. How do we do that?
VB is going to be very small compared to
VCC.
VCC.
So
So we can use resistive divider, no?
Oh yeah, that's true. That's a solid circuit that works, no, for this. Correct. So VB is less than VCC.
Yeah.
That also we know. Okay. So use a resistive divider. Nice. I like that idea. So shall I redraw the circuit?
Or we'll copy this to a new page.
Copy this to a new page and draw that part.
Yeah.
We want to get rid of this, no?
Yeah.
And use a resistive divider. So what we'll do, I'll move this a little bit. So VCC, no? Resistive divider.
Okay.
And this one is the collector voltage.
Yeah.
So now maybe R1 and R2.
R2.
So we still need to find out VB, no?
Yeah.
That's easy. I think we know this now.
Yeah.
This is correct?
Yeah.
Oh, then we can choose R1 and R2 such that I get the right VB. So we know what current we want. We choose the resistor and VB. Then we choose R1, R2 such that we get the right VB. This makes sense.
So here we are assuming base current is 0.
Correct.
Correct, no?
Correct. Oh, you're complicating things a lot.
Because VB,
That
if
is
I had to
true.
write like that.
Correct. We are assuming that base current is 0. Right? Oh, that's true. If base current is not 0, you can't write this. So shall we write it with the base current? So then what you have to do, you have to assume that the base current, it is drawing some base current. So this current the current through R2
Hmm.
will include VB by R1
Hmm.
and this base current.
But maybe because base current is very small.
I'll draw it like this.
Yeah.
Huh?
Yeah.
If
Yeah.
is small.
Yeah.
In fact, so IB should be much smaller than VCC by R1 plus R2.
Yeah.
If this is valid, it's perfectly valid. So we just choose R1 and R2 to be to satisfy this condition. Correct? Okay. But you can't choose it too large also, because then the voltage drop across
Yeah.
IB times R2 is the
Correct.
additional voltage drop.
Correct.
That should also not
Correct.
change. So there will be some range,
Yeah.
right, of R1 and R2 that will work.
So if we Thevenize that portion,
Correct.
it's V Thevenin will be
That is true. So we'll create a Thevenin equivalent for that portion.
yeah, just
So,
for the understanding.
Just for the understanding. So I understand. So here it is not just VB.
Correct.
You now have VB in series with some resistance.
Correct.
Perfect.
Correct.
Perfect. So is what we want to find.
Yeah.
Let's find out what that is. So open circuit voltage, right, and Thevenin resistance.
Yeah.
So Thevenin resistance seems to be R1 parallel R2.
Yes, because
Correct.
VCC goes to 0.
VCC goes to 0. And V Thevenin
That
will
we
just
have
be
already.
VB, no?
Yeah.
Is VB. Correct?
Yeah.
Oh, okay.
There we don't have to approximate.
We don't have to approximate.
Yeah.
That is true. So shall we draw the circuit with the
Yeah.
Thevenin?
Yeah.
Just so that people will understand. So if I have like this, I'll remove this portion.
Yeah.
It's getting very busy.
Hmm.
So now all I have to do is add a Thevenin
Yeah.
equivalent here. Perfect. And this can carry IB, no?
Yeah.
So this is R1 parallel R2,
RB.
which is RB. Shall we just call it RB?
Yeah.
So the actual base voltage is VB minus IB RB,
Exactly.
right?
Yeah.
And that minus 0.7 is what will appear at the emitter.
Yeah.
Perfect.
Yes.
Perfect. So this voltage is perfect. So then this is 0.7 volts. That divided by RE will be the current,
Correct.
and so after that you go the same way. Oh, perfect. Nice. So now we can choose R1, R2, RE, RC such that the device is in the active
region.
always, right? Oh, perfect. Is there a name for this?
I don't know.
We will ask the students to do some research
Yes.
as to what the name for this could be.
Yes.
Huh?
Hmm.
We will cover it.
Yeah.
We'll in the next lecture.
We will uncover it.
We'll uncover it in the next lecture. Correct.